there's reason to check other problems. Let's see if I can find us another one. Z minus 5 over z plus 1 equals to 4/5. See if we can solve this one. Z minus 1 over z plus 5. Well, that's not the problem that's in the homework. But anyway, this is I changed the problem. That's okay. We'll work a similar problem. One, your homework has different numbers, but that's okay. How would you solve a problem like this? What would you do? Any ideas? Any ideas, Mr. Stephen? No. How about in the back? Anybody in the back got a suggestion? No suggestions. I feel like there were more people here. Like this class started out big, but 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. I guess I've only lost a couple, but I don't know. What I would do is just cross multiply. So this gives me 5 times z minus 1 equals to 4 times z plus 5. See if we do that step, basically called cross multiply. So see, multiply, basically what I'm saying is multiply this equation by 5 times z plus 5 is what I did. So when you do that, when you multiply by 5 times z plus 5 cancels on the left-hand side and 5 cancels on the right-hand side. So just generically speaking, this is just a pattern that I would encourage you to kind of hardwire. If I want to solve a over b equals to c over d, it's often useful to rethink of this equation instead as the related AD equals to BC, you know? So this is another version of that, assuming b and d are both non-zero, all right? So that's the algebra step. And then once you've done that, well, this is easy to solve, right? That's 5z minus 5 equals to 4z plus 20. I think we're back into week 1 of this course, right? This is like what we started with, one equation and one unknown, right? And so that gives me z equals to 20 plus 5. So apparently z is equal to 25. And of course, we can check our work, right? It's a good idea to check work. Let's check our answer. Check it. So 25 minus 1 divided by 25 plus 5, that's 24 over 30, which is 6 times 4 over 6 times 5, which is 4 over 5, which is, yep. Hooray, it worked. Let's see here. Here's another one, 2 over x plus 6. Two over x plus 6 equals to 1 over x minus 1. How do we solve this? I would suggest cross multiply again. I mean, sometimes, well, cross multiply is one thing to do. Another thing you could do is just invert the equation. You know that? Another strategy would be this. If I have, 1 over a equal to 1 over b, I can trade that for just a equals to b. Or more generally, if I have like a over b is equal to c over d, I can trade that for like b over a equals to d over c. This is another thing I can do to equations. I can flip both sides. So, hey, you guys, choose your own adventure. What do you want me to do? Flip the equations or cross multiply? Cross multiply. All right, we have a winner. So 2 times x minus 1, 1 times x plus 6. So that gives me 2x minus 2 is equal to x plus 6, which gives me x is equal to 6 plus 2, which gives me x is equal to 8. And we can go back and check. We get 2 over 8 plus 6, which is 2 over 14. And that's equal to 1 over 8 minus 1, which is 1/7, right? So, yep, it works. So, actually, I claimed that this was the next logical step to what we've been doing before this point. I'm not so sure that's entirely a legitimate claim. It seems to me, actually, now that I get into these problems, that the techniques for solving these equations are a little bit divorced from the simplification stuff we were just doing, admittedly. Anyway, I shut up, and you guys have a good weekend. Although it always feels strange to tell you that on Wednesday.